All right, so let's write down solving quadratic inequalities. Let's remember quadratic is when we have a function that has that squared. And inequalities is when we use these symbols. So let's go ahead and review what an inequality does or what it means. Let's say I say x is greater than 4. What are numbers that are greater than 4? 5 and up, right? So we've got 5. Can we say decimals too, like 5.5, 6, 1,000, a million? How about 4.1? How about 4? No, why not 4? Right, because it's the same amount. It's not equal to 4, it's only greater than 4. So not 4. So when we have inequalities, the reason that we use a number line to represent them is because there's so many solutions that we don't want to list them. So solutions to inequalities are represented. All right, so first we're going to graph x is equal to 3. So when we have x is equal to 3, that means we have 3 on a number line, and then we put a point to represent 3. When we have x is greater or equal to 3, this is my greater sign. And this down here, it's like half of an equal sign, so that means equal. And when we put it on a number line, we put 3. We know it could be equal to 3, so I'm going to put a solid point on there. And anything greater than 3 is 3.1, 3, and then we go to 4. And all of these points make up the rest of the solution. So when we talk about greater or equal to, we know we have a solid point. And remember, with interval notation, we use brackets when we have that equal sign. Then we have x is strictly greater than 3. And here's my greater sign. And notice how there is no equal sign, so it's not equal to 3. So on my number line, here's 3, and we can say that it's 3.1, 3.2, 3.3, and anything that is greater than 3. But we need a placeholder, and that is why we use that invisible circle or that empty circle. So we know we start at 3, but we're not including 3. So in this case, we use an open circle, and we use parentheses when we're talking about interval notation. Any questions so far? All right. We're going to do 3 examples. We're going to do an example solving by factoring, an example when we solve by square root method, and an example when we solve by the quadratic formula. So for the first example, we're going to use factoring. We're going to solve by factoring. So way back in the day in Algebra 2, actually just in December, ha ha ha. So in December, we learned factoring, so we're just bringing it back. All right, so my equation is x squared greater than x plus 2. Now, when we solve, we want to change that inequality to an equal sign because we're going to solve it just as if it were an equal sign or an equation. So x squared equals to x plus 2. And the first step, whenever we solve by factoring or by quadratic formula, we need to make sure it's in standard form, which means it has to either equal to 0, equal to f of x, or equal to y. I like my a values this one to be positive. So I'm going to move everything from the right side to the left side. We're going to do them at the same time. So we're going to subtract x from both sides, and then we're going to subtract 2 from both sides. When we do that, we end up with x squared minus x minus 2. These cancel, and give us 0. So now we have our equation in standard form. Questions so far? All right, let's go ahead and put ones where they belong. And let's label our A, our B, and our C. So A, B, and C. Remember, my A is the one that has x squared on it. Then we've got my B term. And then we have my C term. This is -1, and we've got -2. Who remembers what to do when we have our A, B, and C, when we're factoring? Now remember, factoring is when we have that I. Right, good. We're going to multiply A times C. So A times C, 1 times -2 is -2. And then the remaining value B goes in the denominator, or not the denominator, I'm sorry, the bottom. We're working with fractions and geometry. Denominator. All right, so then this top number tells us what we're going to do to our factors. Because it's negative, we're going to subtract them. And this is where we put our factors. So what are the factors of 2? Remember, multiply numbers that multiply to give us that number. 1 times 2. Yes, thank you, 2. And if we subtract those numbers, do we get 1? 2 minus 1 is 1, good. So then the bigger number, or the bigger factor, will get that negative. So my bigger factor is 2, so the 1 is positive. Questions so far? All right, let's go ahead and set up our factors. We've got x plus 1 and x minus 2 equals 0. So this plus 1 comes from here, and this minus 2 comes from there. Any questions so far? All right. Now here, all we're going to do is solve. So we've got x plus 1 equals 0, x minus 2 equals 0. So my first x is -1 because we subtract 1 from both sides. Over here, we add 2 to both sides, and we get x is equal to 2. Woo, we're done with step 1. Yes. The next part, easy part. Well, I mean, this part is easy too, right? Everybody agree? Yeah? All right, here we go. So now, the next thing we need to do is we're going to put those numbers on the number line. So I'm going to have a number at -1 and a number at 2. If we look at my original equation, are we going to have an open circle or a closed circle? It's going to be open because there's no equal sign. So let's put 2 open circles at -1 and 2. Questions so far? All right, so now we're going to use a test point. We're going to grab this original equation and we're going to rewrite it. So we're going to write the original equation. And we're going to test whether or not 0, I'm going to put 0 here because it's in between -1 and 2. And I'm going to test if 0 is part of my solution set. Which means everywhere we see an x, I'm going to put 0. So we've got 0 squared and then 0 plus 2. Which means we get 0 is greater than 2. Is that true or false? Is 0 greater than 2? That is false. So because it is false, that means 0 is not part of the solution set. Going to shade away from the 0. So because 0 is not part of my solution set, we're going to shade away from it, where my shading does not touch the 0. Any questions so far? All right, so now what's left is for us to write it in interval and set notation. I'm sorry, interval and inequality notation. So we're going to start with inequality notation. And inequalities when we're using the greater than or less than signs. So we're going to put x and r and put -1. And all these points, are they greater than -1 or less than -1? Less than, right? And then we're going to put x and then 2. And all of these points are greater than 2. And those of you that still have a hard time with your inequality signs, if you put your variable first, notice how it matches the arrow. And then on this side, it's going this direction, and this one's also going that direction with the 2. All right, so now it's whether or not we're going to use the and or the or. Is it possible for a number to be less than -1 and greater than 2, or is it or greater than 2? Yeah, it's going to be or. So we need to put that or in there. Question so far? Now we have a long weekend ahead of us, huh, guys? I'm sorry. All right, let's get this over quickly. Now the next one, we're going to do interval notation. Wakey, wakey. We're going to have 2 of them. We're not used to this. This is the first time we will do this. We're coming from -infinity because that's where my arrow is going. So we're going to go from -infinity to -1. Now, anytime we have infinity, are we putting a parentheses or a bracket? Parentheses. Always parentheses with infinity. Now, -1, because it's an open circle, are we going to use parentheses or bracket? Parentheses, kind of like if you're making a circle. So if it's open circle, you want it's curved. Parentheses are curved. I don't know, that could help. All right, so for the next one, or we use the U to represent or. So this means or. And now the other one for the 2. We're going from 2, and then the arrow takes us to +infinity. For the 2, it's an open circle, so we're going to use parentheses. And then infinity, what do we always use for infinity?